So today I'm going to be talking about counters, and we have a counter up, which can be found in Timers and Counters tab. And this is a counter up CTU. And before I go in, I'll quickly go over the parameters. So similar to timers, counters, this counter bit over here stands for a memory address assigned to the counter itself. It usually ranges between C50 to C599. For example, I'm going to quickly name it to be C50. And this is our preset value, and this is the target count at which we want the done bit to be active. So I will set it to be 5 for now. And then we have our accumulated value, which displays the current count value. So each time there is a valid input pulse, this accumulated value increases. So it starts from 0 to 1 to 3, 2, 3, 4, and so on. As for our outputs, we have CU and DN. So we have CU right here, which turns on whenever the input is high, and it produces a logic high every single time the input is high. And we have our done bit over here, which turns on whenever the accumulated value is equal to or greater than the preset value. So for example, if this accumulated value is 5, it means our done bit turns high. If it's 6, it turns high, and so on and so forth. But if it's 4, this done bit is low. So I will quickly do a mini project where I will turn on a lamp after I press the start button 5 times. So for counters, I need a input. So I'll drag the input code right here, and I'll drag the address of my start switch, which is going to be this one. And I'll quickly rename it to be start. And in another rung, I want to use this counter, the done bit of the counter, to turn on my lamp. So I want to turn on the lamp after I press the start switch 5 times. So I can rename that, set the address to be C50, and because I want to use the done bit, I would do /dn. And I will change this to be counter 1. And I want it to turn on the lamp, so I will use an output coil. And I'll drag the address of the lamp right here, and I will change this to be lamp. I will just say lamp up just so that I know that I'm working with counter ups. But yes, this is a very simple example, and let's see this in action. So when I download the code, and just as you can see that my accumulated value is 0 right now. So after I press the start button once, you can see that the accumulated value has reached to be 1. And you can see that both of my output coils are in logic low. But when I press it, my CU, which is my enabled bit, is logic high. And as you can see, the second time I press it, my accumulated value is 2. And I keep on pressing it until this number reaches 5. And as soon as it reaches 5, because 5 is greater than or equal to the preset number, which is also 5, my done bit gets activated. And because of that reason, my lamp energizes, which can be seen right here. And I can press it one more time, and 6 is still greater than or equal to 5. So my lamp continues to stay energized regardless of how much my accumulated number is. So I will quickly go back, and now I will work with CTDs, which is the counter downs. So I will drag the timer/counter. I'll be working with CTD, which is countdown, and I'll drag that counter down, and this is what it looks like. And as for the parameters, we have counter, which is the address of the counter itself, going from C50 to C599. We have our preset number, which is the final, or like our goal number for our counter. And we have our accumulated value, which displays the current countdown progress. However, it is important to note that because this is a counter down, instead of increasing, it will decrease. So unlike over here, we have our counters, which goes from 0 to 1, 2, 3, 4, and 5, and so on. This will go from 0 to -1, -2, -3, and so on for each valid pulse. That means it's important to note that we set this preset value to be something that we can actually achieve. And what I mean by this is we can't set this preset number to be 5 and start at 0, because no matter how many times we push that start button, it will never reach 5 because this is a counter down, so it will always decrease. So I will quickly fill this spots up. So this would be my address, C5. Because our 0 is already taken, I will set this address to be 1. And I'll set my preset number to be a negative number. So I'll set that to be -5. And as talking about my outputs, we have our enable bit, which will turn on every single time our input is high. And we also have our done bit, which turns off once the accumulated value reaches the pre-value, indicating that the countdown is complete. This is very opposite of CTUs because it starts with a logic low for down bit and then it switches to logic high. But over here, it starts with logic high and then after it reaches that countdown, it will turn into logic low. And this is because each time you click on the start button, it decreases. So it goes from 0 to -1, -2, which is still greater than or equal to -5. So 0 is greater than or equal to -5. So that means that this done bit is high. And I will do a simple example of turning off a lamp after 5 presses. And I'll quickly drag a normally open contact, and I will drag the address. I'll turn this into a start switch and drag that address here. Change this to be start 2. And I'll drag another normally open contact, and I want to use this done bit. So for that reason, I will set this to be C5 colon 1, and I want to use the done bit, so I'll use /dn. And I will set this to be counter 2. And using this counter, I want to energize a lamp. So I'll just use this lamp real quick. But before that, I will have an output coil and drag the address of the lamp right here. And change this to be lamp down. So let's see what it does. You can simply run the code. Oh, ignore the first lamp because I haven't reset that counters. But as you can see, my second lamp is automatically on. That this is because 0 is greater than or equal to -5. So my done bit is already high. So I press this start button, and you can see that the accumulation is -1. I press it again, -2, and I do that until it reaches -5. And -5 is still greater than or equal to -5, so the done bit is still active. So I press it one more time for it to turn -6, and finally my done bit turns into logic low, which de-energizes the lamp. So our lamp is off now. Now I'm going to talk about reset. So reset or res button right here is an instruction that is used to reset a counter. So it either resets the CTU and CTDs. This is very similar to timers that we used earlier, and it resets to 0 once it receives a valid input pulse. And it clears this accumulated value without changing the preset values. So this is what a reset button looks like, and the inputs are a counter that needs to be reset. So for this example, I'm going to reset the CTU, and I can set this to be the address of the CTU itself, which is C50. And the output is that it resets this accumulated value to be 0, and then the done bit and the enable bit are also de-energized. So I'll do a quick example of manually resetting this counter using a start button. So I will use this start button for the reset, and for that I will have a normally open contact and drag the address of the start bit and change this to be reset CTU. So every single time I press this button, it will reset my CTU. So let's see this in action. I'll download the code and run it. So as you can see, I press it 1, twice, and 5 times for the lamp to return on. And now once I press the reset button, which is this one over here, the lamp is off because the CTU is the counter has been reset, and the done bit has also returned to be 0, which means that our lamp is de-energized. And this, you can reset any counters in the middle of the counting process as well. So if, let's say, I don't complete my count and I hit the reset button, it still reduces the erases that number and sets it back to 0. And now I want to talk about how we can manually reset after, let's say, the counter has reached that count. So, okay. So for that, to manually to auto reset, I will use the same coil reset, and I'll do that for CTD. So I'll drag the address, which is going to be C5:1. So this will reset. This reset coil is for my CTD over here, and I'll have an input pulse input right here. Oh, I want it to be before that. Okay. And as for the input itself, I want this done bit to be its input. So every single time the oh, actually, because I want to be I'm using a CTD, I realize that the done bit is always high, which means that every which means that it continuously resets it. So instead of having a normally open contact, I will have a normally closed contact because I'm working with CTDs. So that means that I want an opposite or an inverse um, relation over here. So every single time the CTD, the done bit is high, I want to not reset it. And then as soon as it turns low, I want to reset it. So I can change this address to be C5 colon 1, and I want to use the done bit, so I'll do DN. This is going to be my counter 2. So let's see this in action. I will download the code and I'll run this. So here's our start button for our counter down. And as you can see, every time I press it, my accumulated value is increasing to be -3, 4, and 5. And this now when I press the button, it reaches to be 0. It reaches to be -1. Okay. There is a problem here because we wanted it to turn it to be 0. So when we press the reset button, it will reset the accumulated value to be 0. But because the time differences, because there's a difference between the hardware scan cycle and software scan cycle, this input, whatever input pulse that I gave it, it actually was detected twice, which caused the counter to reset and also increase the accumulative value. So it not only reset it to be 0, it turned off the lamp, and also it increased it to be -1. And we will solve this issue by using OSR. So I'll just show you one more time. Yep. So we'll solve that issue using OSR. So this is OSR. This is my OSR. So it stands for one shot rising. And one shot rising is an instruction that ensures that the signal that we push is only recognized once per activation. So it detects the high edge of a signal. So it, for example, being from 0 to 1, and sends a single, which is one scan pulse, to the instruction. So even if my start button is on. So this will prevent our double count, which was the case with this one, where I pressed this input, I pressed the start button once, and it reset it, but it also increased to 1. So I can quickly drag that. This is what it looks like. I will drag that in here, my marker address. So I will put an address like B3, 0/1. That can be my address for this OSR. And as an output, it produces a single pulse output from one program scan. So when the transition input is from off to on or on to off, like on to off. So we will do a reliable auto reset using this without any unwanted increments. So now that I have this OSR, this solves my issue with the accumulated value right here. So I will reset my timers and counters, and I'll download the code and run it. So as you can see, I reached my accumulated value and one more pulse, and that pulse was regarded as only one single pulse, which means that you reset the counter, and it wasn't used to kind of like increase the accumulated value. So this is very neat, and yeah. So this is because the OSR only responds to a high edge and it ignores the continuous high state. So it eliminates any false resets and it guarantees accurate counting. So in this section, I will use two counters instead of a separate start and stop buttons to control a motor operation. So we will use one counter for the motor to start the motor and the other counter to reset both the counters and also stop the motor. So let's start it by So let's start with the initial logic of starting a counter. It's starting a motor itself. So I will use a normally open button right here, and I will give it the address of the start button. Change it to start. And this start button will essentially have a counter attached to it. And I'll be using a counter up just to make it easier. And I'll set this address to be C5. And I want this counter to run only one time. So essentially, we will use this start button to start the count, and then as it reaches 1, it will start my motor. So then I will be using my done bit to start the motor, and I'll drag a normally open contact. I'll add the address of the done bit over here. So I'll use C5 0/dn. It's going to be my done bit, and I will set this to be C1 because this will be my first counter. And once this is activated, I want to turn on my motor, which I will use this indicator light as my motor. So I will have that, and I will rename this to be motor. Great. So after I turn on the motor, let's see it in action. As you can see, once I press the start button, my counter has reached the count, my done bit is energized, and therefore my motor is energized as well. Now I want to press it one more time to turn off the motor. And we can use that by including one more counter in here that will kind of act as a way to reset my counters. So a way I can do that is by including a parallel, including another rung in there, and I'll have them in parallel. So I'll have another counter. I will still be using CTU, and I will set this to be C5 1. And as you can see that once we press the start button, our count is already increases to 1. So I want my second counter to start after I press the start button twice. So my preset number is going to be 2 for that reason. And then using this done bit, I will reset these both counters. So I will drag a normally open contact right here, and I'll have this reset right here, reset button. And since I want to reset both of these counters, I will have them in parallel. So I will have another normally open contact, a rung, and I will have 2 reset buttons right here. So once my second counter kind of turns on, which is C5:1/dn, I will use that to reset both of them. So I will edit this. Continue. This will be my address of the first counter, which is C5:0, and this will be the second counter, which is C5:1. And there you go. I will reset both of them. And like like I mentioned earlier, when we're using automatic reset, we know that our there's a delay between our scan cycles. So once I press this start button again, I know for a fact that this accumulated value is going to increase by 1. So because I only want to consider having one pulse, I will use OSR. And I'll put that here. And I'll set this OSR to be B3, or address to be B30/1. What this OSR does is that it's an instruction, and we'll use it to ensure that each button press is only registered once, and it prevents any false multiple counts, and yeah, it only focuses on the rising of the signal instead of the high signal itself. So let's see it in action. Right. Oh, let me reset. Or actually, there you go. All right. So let me run this program now. So when I press this start button, we can see that both the counters increment by 1. And once the first counter, C1, has increased its preset value of 1, its done bit energizes, which means that my motor turns on. So when I press the start button again, the accumulated value of this thing turns to be 2, which means that my done bit then energizes. And right here, after my done bit energizes, it triggers the resets for both of these timers. That's why you can see that both of them is 0, and because this is already 0, this done bit then turns into low, which means that we are no longer getting power to our motor, so our lamp turns off. We also use OSR, which is a one-shot rising instruction, to make sure that each button press is only registered once and we don't get any false multiple counts. So, yay!